Hi guys, welcome to my channel Python Short. Hope you guys are doing well. Today we are going to see how to design a logical OR gate using a simple neural network. So it's very important to understand this concept because this kind of question helps you to relate your AI terminologies or your AI knowledge with the hardware part. So you can apply for the companies like Intel, Qualcomm, Nvidia, AMD, analog devices where these concepts come handy, where most of them are moving towards the AI optimization things. So let's see. First of all, let's see how a OR gate looks like. So this is simple OR gate where we have two inputs x1 and x2 and output as y. And then we know for each gate we have something called as truth table where we define the inputs and we calculate or we get the output. So OR operation is nothing but a simple addition operation. So now here 0 plus 0, my output should be 0, correct? So let's finish this truth table. So for this value, that is nothing but 0, 0, my output will be 0. For 0, 1, 0 plus 1, 1, 1 plus 0, 1, and then 1 plus 1, 2, but in digital electronics, we take it as 1 and then 1 carry like that, but we don't need that. We just remember this for 1 and 1, it is also 1. Now, OR gate also we call it as a linear model because here only one of the input is 0 and others are 1. So we can linearly separate it easily. That's why this is also a linear model. Now, for linear model, using a neural network is very easy. There is something called as perceptron. Okay, as I explained in earlier lecture when we were designing a AND gate using neural network, perceptron is nothing but a simple ANN, that is artificial neural network, where we have two inputs and a single output. So for two inputs and one output, we get a perceptron formula as output will be always equals to 1 if and only if my equation x1 w1 plus x2 w2 plus b becomes greater than 0. Now from where this equation come, I have explained it in the previous lecture of a AND gate, but here still I'll give you a gist. We know this equation for linear models is y equals to mx plus c. Now here my m is nothing but my weights and my c is nothing but my biases. So here we get a equation as y equals to wx plus c. But as we have two inputs, so that's why we have x1, x2, and with respect to that, w1, w2 are their weights and then the bias. And then we write here 0 otherwise. Now, to design a neural network where we get output as 1 when this condition is satisfied and 0 otherwise, we need to see the calculation. We need to set some initial values for W1, W2 and B for the calculation. You can try different combinations of values for W1, W2 and B. So I'll directly jump to the solution what values you can set to get this functionality of OR gate using a neural network. So here I can set W1 as 1 and W2 as 1, but my bias I'll set it as minus 0.5. Now when I set this values, what my output becomes? My output will be like x1 w1 is 1 plus x2 w2 is 1 minus zero point 0.5. Now this should be greater than 0, okay, for my equation to satisfy. Now let's write a table again and check the values. Okay, so let's say here x1, here x2, here I'll something write sum, which will be nothing but the equation. This calculation I'll write here. And then finally we have output. Now let's start with the very first input where my x1 is 0, x2 is 0. When I put this x1, x2 in this equation, 0 plus 0 minus zero point 0.5, my sum will be something like as minus zero point 0.5. This is less than 0. So my output will be what? 0. Next is 0, 1. Put it here. You can see this is 0 plus 1 minus zero point 0.5. This will be nothing but plus zero point 0.5. This is greater than 0. So my output comes 1. Then next is 1, 0. When I put this condition, my output is plus zero point 0.5. This is also greater than 0. So my output is 1. And then for 1, 1, if I put it, I get 1 plus 1, that is 2 minus zero point 0.5. That is 1.5. This is also greater than 0 and I get as output as 1. So when I set these values, that is nothing but W1 to be 1, W2 to be 1, and then my bias is minus zero point 0.5. That time we get the values which we desired for making a OR gate using a neural network. So let me just draw it here how a basic neural network will look like in a diagram manner. Say this is one of my neuron for perceptron. This is my x1, this is my x2. Here I'll have something called bias and this will be my output y. This is x1, this is x2. This is W1 which I am setting to be 1 initially, and this is W2 which I am setting to be 1, and this is my bias which I have set to minus zero point -5. So in this way you can design a OR gate using a simple neural network. The coding part we will be seeing in the next lecture, how you can code and create this neural network to test your OR gate as well. So for more understanding, stay tuned to this channel and keep learning. If you like this video, please subscribe and share as much as you can. Thank you.